All right, here's this bell work. So we got this equation that we got to solve, and it looks like we got some distribution and combining some like terms. So we'll solve for x here, and that means that I'm going to distribute this value. Now, some of you say, well, we're just distributing a 4 right here. No, it's not just 4. Remember, it takes the operation to its left as its sign. So that's really a negative 4 right there that I'm now distributing into this set of parentheses. So from there, first off, I'd have negative 4 groups of 2x, because that's the first multiplication, and distribution is always multiplication. And then also I would have negative 4 groups of 1, like this, okay? So, from those two distributions, negative 4 groups of 2x's, that'd be negative 8x's. And then also negative 4 groups of 1 would be negative 4, like this, okay? Now nothing else really changed, so we still got the 3x plus 2. Then that would read 3x plus 2 minus 8x minus 4. Now this equals 7. And now that we got this, after the distribution, there's no other distribution. We should look to combine any like terms that we can. And there's two sets of like terms. The x's, which I will do first. You could do the numbers first if you wanted to. But 3x's minus 8x's would result in negative 5x's. And then 2 and negative 4 would combine to give you negative 2. And this still equals 7. Okay, so after distribution, we had 5 terms, but we've narrowed it down into 3. This becomes a two-step equation. I need to isolate my x's, so I'm going to have to add 2 to both sides of the equation. That's a 2. To zero out that negative 2. So I'll still drop my negative 5x, which equals right now 7 plus 2, that's 9. And then finally divide both sides by negative 5, the coefficient. Is going to make that a phantom 1x, x equals negative 9/5. And then, of course, I'll check. So I'll replace the x up here with negative 9/5. There's 2 x's, though. And then I will check for truthfulness. So there's my question mark. So negative 9/5. Yeah, so in the calculator, that's what I'm using here. So I got 3 parentheses, negative 9/5, and I'm using the n over d button there. And yeah, if you're using the decimal, that's fine. So plus 2 minus 4 parentheses 2 parentheses negative 9/5 again. Close those parentheses, plus 1, and then close the parentheses. So if I type this in correctly and negative 9/5 makes this a true statement, then it is a solution. So I push enter. Yep, I got 7. So that means that negative 9/5. If I replace x with negative 9/5, it does actually give me a true statement right there. And that also means that if you replaced x with any other value other than this fraction, yeah, it would give you an incorrect answer. Or it would be false at least. There's our objective though. I can solve an equation that requires many principles of equality, even when there are x's on both sides of the equal sign, whether there's distribution or even combining like terms. Take a minute and copy that down, please. All right, now do remember that you do have a space on your worksheet that you should be able to write this down. So you don't have to put it on scratch paper. But really what we're looking at here in the objective, there's nothing different than what we've been doing, right? Distribution, combining like terms. It's just now you're going to see x's on both sides of the equal sign. But we can operate with those with principles of equality. We just have to make sure we're looking at like terms when we use our principles of equality. That may not make sense now, but hopefully will by the end of the lesson. So once again, what is a solution? A solution to an equation is where we find a number that we can replace x with to make the statement, which is an equal statement, a true statement, okay? That's why the real question is what value of x makes the equation a true statement? Because we will be checking for truthfulness on each of these. But where before we were kind of writing those out, now they're kind of long in the beginning, so we just kind of write over the x, and then we can use the calculator to really check all that stuff, okay? Of course, you're still welcome to show the work if you'd like, but most students prefer to just do it on the calculator, and that's fine. And then in addition to that, you'll be replacing the x's. You'll see there's going to be x's to replace on not only the left or right side, but both sides, left and right sides of the equal sign, okay? So Here's our principles of equality. Do recall that when you're using addition and subtraction, that is to make zeros in the equation, right? And the reason why we would want to make zeros is to be able to ignore those zero values. That's really just to help us to isolate the x's or to get rid of values on the side of the equal sign. And then multiplication and division, this is used to make ones. And then in addition to that, when we make ones, that's usually specifically for the coefficient. Okay. Now that also means that we pretty much don't use multiplication or division until we are finished using addition or subtraction. But even then, all these principles of equality we don't usually use until we have used distribution and also combining like terms. Once we get finished with distribution and combining like terms, then we look to use these principles of equality. All right, so here's our first problem. We can see x's now on both sides of the equal sign, just like we hopefully expected at this point. Now, along these lines, it doesn't matter if you choose to keep the x's on the left or on the right, okay? Now, when I do this, I like to show, just kind of above everything here, that I'm going to keep the x's on the left and then the numbers on the right. Most students will keep x's on the left and then put the other numbers. And when I put numbers here, I'm talking about the constants, the non-x terms. Put these on the right, okay? So we can go through this problem here. It just, I like to scan it from left to right. Yeah, that's a good question. So putting the x's on the right here and then the numbers on the left won't change. It won't change your final answer. So, and I'll show how that works at the end of this one. But scanning from left to right, we got the 4x. That's an x term. See how it's kind of on the x side of the line here? So that means that I don't want to zero that out. But if I see some non-x terms, I will want to zero those out, okay? So here's a plus 4. See, it's on the x side, but it doesn't have an x. That means I do want to zero this out. Okay, so I'm going to use, that's a plus 4, so I will use minus 4 to zero that out. Now, if I do it to one side, because this is a principle of equality, I do need to do it to the other side. So with where the negative 2 is, I'm going to do minus 4 right there. Okay, be careful because sometimes I've seen students put it under the 8x, where they say, hey, minus 4, and then they say they got 4x. No, you can't do that either. And the reason that is because these are not like terms. You can't combine unlike terms at any time, okay? So don't put the minus 4 under an x term. You have to combine it with another like term right there, okay? So let's get rid of that garbage and go back to what we should be seeing, which was the minus 4 with the negative 2. Now, moving from left to right, yeah, I mean, you can do this any way you want, but I'm going to drop my 4x. And then the plus 4 and the positive 4 minus 4 there. That's going to be the 0, like we wanted. And then this will equal negative 2 minus 4, which is negative 6. And then my positive 8x, that will drop as well. Okay? All right. So that was just to zero out this plus 4 right here. And we did, just like we wanted. But now, continuing to scan now this new equation, which is the same as this one, it's just shown differently. So I scan this, I know the 4x is on the x side of things. I see the negative 6, which is on, not because I've crossed over the equal sign here. I see it is on the number side of things. So I want to keep it there. But see, now since I'm on the number side of things, here's an x term. We don't want the x term on the number side of things, so I'm going to zero that out. So that's a positive 8x. I'm going to zero it out by subtracting 8x. But if you do it to one side, you will need to do it to both sides of the equal sign. So starting on the left there, 4x minus 8x's would be negative 4x's. And this would equal, yeah, that negative 6 will just drop. And then 8x minus 8x, yeah, that zeroes out just like we wanted to. And I've talked about this before. This is what it means to take control of these equations, all right? I haven't changed values of the overall equation. I just have been changing the way it looks. And the final thing I'm going to do here is force the coefficient of x to be a phantom 1, which will then show us just x. And right now the coefficient is -4. Remember, the coefficient is the number being multiplied by the letter, so I'm going to have to divide both sides by, well, -4. So here I get x equals -6 over -4. I'm going to put that in the calculator, -6 over -4. And it will show me, the calculator will even simplify it for you as 3/2 right there. And it is positive, by the way. Some of you may prefer to use 1.5. And like I said, I think the homework wants the fraction on these types of problems, okay? But that should be our solution. And I mean should be because we're going to go back up here and just check, right? I'm going to replace this x with 3/2. And I'm going to replace this x with 3/2. And then we're going to check for truthfulness. So here's my question mark above the equal sign. So in my calculator, just putting in the left side of the equation, you could do the right side first if you wanted to, before parentheses, 3/2, and again, I'm using the n over d button. If you wanted to do 1.5, it should still work, plus 4, and I push enter, and on the left side, I see that I get 10 when I pushed enter there. Now, when I put the right side into the calculator, I should also get 10, right? So I push -2 plus 8, parentheses, 3/2, again, there's the n over d button, close parentheses. And when I push enter here, I should expect to see 10. I do. Bam. Okay, so on the left side, we got 10. On the right side, we got 10. That would have made that a true statement, which means that x equals 3/2 is the actual solution to this equation. Now, I know I kind of went through that a little bit slow. Hopefully that helps. So for those of you that are like, I can do this pretty quick, that's good. But for those of you that are struggling, hopefully that helps, okay? Now, yeah, this is, the new concept here is where, right, we've been subtracting numbers or adding numbers to both sides of an equation, but now you can see, you can do that even with x terms like this. You can do that to both sides if that's what you want to do. Now, of course, we would hope that there's more purpose than just that you want to do it. Not that I think anyone wants to do any math, but you can do that with x terms. You can start zeroing out x terms. All right, so here's this one, and it is pretty similar to that last one. So once again, I'll prepare my principle of equality here with my upside down t. And once again, I'm going to put the x's on the left and then the numbers on the right because this is a very common setup for students. But again, I will emphasize this. It doesn't matter if you put the x's on the right and the numbers on the left, okay? Now, in scanning this one from left to right, I see right off the bat, there's a non-x term, right? This one does not have an x. So that means I need this thing to be a 0 so I can just ignore it. Now, it's a -2. To zero that out, I'm going to put +2 here, okay? Now, if I'm showing this on the right side of my principle of equality setup. Now, I got to do it on the right side. Once again, please do not put it under the 2x. Those are not like terms that you can combine, okay? So we have to put it under the 14, so that's +2. So scanning this, -2 plus 2 is 0, just like we want. And when you drop this 14x, make sure you include the negative from the minus sign on its left. This will equal, drop your 2x, and then 14 plus 2, it's +16. So again, the positive I'm showing is +16. And that now is our new equation. It's the same as the old equation, it just looks different, that's all. Now, continuing my scanning, right? So the -14x term is on the x side of things. That's good. We want that. But the 2x is on the number side of things. Nope, that's no good. So I will want to zero that out so I can ignore it by subtracting 2x. Because that will give me 0 x's in this spot right here, which is what I want, okay? So -14x's minus 2x's, that would be -16x's. This equals, yeah, I'll just drop this red +16. I don't really need to show the positive sign here. Now I don't want -16x's. See how we went from what, 4 terms down to 3, now to 2, and we'll keep it at 2 terms, but it will finally look like x equals on this, right? So I'm going to take that -16 coefficient and divide it by itself to make a phantom 1. It's just if I do it to one side, I got to do it to the other side as well. Okay, so I'm showing the division a little differently because we can. And if I put that in the calculator, 16 divided by -16, enter, I get -1. Now, I think that's the answer, but I do want to check just to make sure. So I go up here and I replace the x with -1. Well, both x's with -1, and I just want to check, okay? So here's my question mark. So in my calculator, I do -2 minus 14, parentheses, -1, close parentheses, and if I could type that in correct, there we go. I got 12 on the left. Okay, but I want to check to see what I get on the right. So 2 parentheses, -1, close parentheses, plus 14. Enter 12. Now, last time I checked, 12 actually does equal 12. That would be a true statement up there at the top. So, since it did make the equation a true statement, x does actually equal -1. That's a true statement. Which then means that x is equal to -1. -1 is the solution to this original equation. But it would also work here and there, but we always want to check with the original equation there. All right, here's one, and the first time we've seen 5 terms in this lesson. You guys try this one out. Try this one out. Take a minute, try it out, and then we'll go over, okay? 1 minute, go. I'm still working to finish up, but I'm going to go ahead and start on this problem. In fact, just a quick spoiler alert on this one. I got x equals 5 on this one, but we'll check just to make sure because, sometimes I make mistakes along the way. So let's show the work on this. And before you start looking to use principles of equality, always check to see if there's distribution or combining like terms. In that order, by the way. And I do not see any distribution, but I do see some combining like terms, right? Starting with that 7x, and I'm going to call that -1x. Some people just say -x, and that's fine as long as you get the same answer here. But if I combine these two, 7x's minus 1x's, I end up with 6x's right there, okay? So this new equation on the left, on the left side of the equation would be -13. That's a positive 6x, so I'll show it as plus. And then this would equal just the right side. Nothing to do there. It's just 3x plus 2, okay? So 5 terms down into 4. So it's already been simplified at least a little bit. And once again, I'm going to choose to put the x's on the left and then the numbers on the right. So, since that's the case, I see this -13. It's on the wrong side of the equal sign because it does not have an x in its term. So I'm going to have to zero that out. And to do that, -13, I'll have to add 13 to it. So on the right side, I've got to combine it with its like term, which is, in this case, the +2. So that would be plus 13 there. Okay, that will zero that out. I still need to drop my 6x. Which now equals 3x, which was dropped. And then +2 plus 13 would be +15. So 5 terms to 4, now to 3. Let's see if we can make this 2, because the 3x is on the number side of things. We don't want x's on the number side of things. So I'm going to have to zero that out too by subtracting 3x from both sides. So what do we get? 6x's minus 3x's on the left. That would be 3x's. Which now equals, yeah, we did zero that out, which was nice, and then I'm going to drop my +15. The last step here is to divide both sides by the coefficient, which is 3. Yeah, now we see here how we get x equals 5. 15 divided by 3 is actually 5. There's the phantom 1 there. It's there, you can't see it. It's lurking in the shadows, which makes these creepy, but you can't see it, but it's there, okay? And of course, the last thing I would want to do is replace the x's with 5 up here, all of them, because there's a few. There we go, all these with 5, and I'm just going to check this for truthfulness, okay? Now, when I put this into the calculator, because I've already done that, because you guys had a chance to do it, I did it in my calculator. On the left, I got 17, and on the right, I also got 17, which means that when you replace x with 5, you do, in fact, get a true statement, and therefore I can feel a lot better about boxing that in right there. Now, if you had put the x's on the right side, the only difference here is that instead of showing it x equals 5, you would have gotten 5 equals x, and it is exactly the same thing. It's just you've switched where the x and 5 are, the sides. But it communicates the exact same thing. This one says x is 5. This one says 5 is x. It's the same thing. Here's this next one. We'll do this one together. Yep, this one we do see some distribution, so we'll have to get right to it. And I will be distributing this -2 here. So right off the bat, that's -2 multiplied by -1. That will give you a +2. And then it's -2. I'm going to call that -9t, -2 groups of -9t's. That would give you +18t's right there. And that's the only distribution we have. So I'm going to bring this down, and we'll bring this stuff down too. Okay. By the way, that's a t, not a plus sign. All right, that's all the distribution, but is there any combining like terms now? Yeah, we got 2, 4, 6 terms. We should be able to narrow this down into 4 terms. And there's no like terms on the left to combine. So I'm looking on the, I'm sorry, the left side. On the left side, there's no like terms to combine, but on the right side, there is. And what do I got here? I got a 2 and a 1 that I can combine to be +3. But also 18t's and a -7t's would result in +11t's. So this still equals 3 plus t. All right. Well, we got to choose which side we want the t's on, in this case, because we're not using x's on this one. And I am going to choose to put the t's, once again, on the left, and then the numbers on the right. Okay? So here's my principle of equality incoming. And I got this 3, which is not a t term, because it doesn't have a t there. That's a plus sign, by the way, not a t. Be careful of that when you see t's. And so I need to zero that out by subtracting 3, but if I do it on one side, I got to do the other side. And again, I'm combining this with its like term. I'm not combining this negative or -3 with this +11t's. It's just 3. So that will zero that out. I'll drop my t here, which now equals, that's 3 minus 3. When I do that, I'm actually going to show the 0 here, and there's a reason for that. Even though I'm still going to drop my +11t's right there, okay? So do be careful on that. I need this 0 here because I need to show some kind of number on this side of things, even though technically we usually make these phantom values. I don't want to make this a phantom value. I'm going to need to see it because I don't want these t's right here. I will make that a phantom 0, though, by subtracting 11t's from both sides of the equal sign, okay? And even, just to show the coefficient of that black t right there, I'll show the phantom 1. So that becomes 1t plus 11t's, which is 12t's. And then this would equal, I'm going to drop that 0 because I do need it. And then 11t's minus 11t's, that's 0. Well, it should have been minus, right? So it's not 12. I should have put minus right there. That would give us -10t's, okay. Now we see the importance of having that 0 there because I need some value to hold this. If you didn't see that 0 there, it wouldn't communicate anything other than that there's a phantom 0, which is why we just need to show that, okay? The last step for us is to divide both sides by the coefficient -10, which I will do in the calculator, making that a phantom 1. So t finally here. Please don't put -0, by the way, as your answer, but 0 divided by -10 is just 0. There's no such thing as -0. In fact, there's no such thing as +0. It's just 0. It has no value. So we took all what we have there with some distribution and then 6 terms down into 4, then 3, then 2, and then 2 again, because we get t equals 0. Now, this one isn't too hard to check. I can replace all my t's with 0s up here. And yeah, please let the calculator do that work for you. But there's my question mark. On the left side, I get 3, because 3 plus 0 is 3. I didn't even need to use a calculator for that, but if you did, that's fine. And then -2 times that parentheses, and then we're going to have to +1, and then -7 times 0. Yeah, that's going to be 3 as well. So that means that gave us also a true statement, which means that t equals 0 is the actual solution to the equation. Now, this one's kind of long, but it's definitely doable. Notice that the work isn't more difficult, it's just more of the work, which doesn't really make it more difficult, it's just more. Let's do this one together as well. And yeah, we do see some distribution on this one, so that's what I'm going to start with my 5. First multiplied by 2, that would be 10. And then I got to distribute with the second rainbow into the second term. 5 groups, again, that's 10 x's, not just 10 x's. So that would give us negative 50 x's, which now equals the right side, negative 8x, and then plus 3. All right, and now, yeah, we're down to 4 terms, which means here comes some principles of equality to isolate my x's. And once again, I will put the x's on the left and the numbers on the right, even though you could switch these, okay? So here's my 10, nope, no x's, so I don't want that there. And when I say I don't want it there, it means I'm gonna zero it out by subtracting 10. But if I do it to one side, I gotta do it the other side there, okay? So there's a 0. Again, when you drop this, it's not just that it's 50x, it's negative 50x, because it takes the operation to its left as its sign. This now equals, I'll drop my negative 8x's, and then 3 minus 10 gives me negative 7. Now, I have this negative 8x on the number side of things. Yeah, that's no good either, so I'm gonna have to zero that out. Negative 8x, so if I add 8x, that will zero that out. But if I do it to one side, I got to do the other side. So negative 50x's plus 8x's, that would give me negative 42x's, which now equals, yeah, negative 8x plus 8x, zeros that out, just like we wanted to, and I'm going to drop this negative 7. Final thing here is to divide both sides by the coefficient, negative 42, to make that a phantom 1. And now x finally equals, just put this in the calculator, negative 7 over 42. And I'm going to keep the fraction on this one, not just because it's pretty, but because the decimal's ugly. The decimal on this one is very, very, very ugly. So I'm going to keep the fraction, and again, on the homework, I believe it wants you to put the fraction in there, okay? Now, the last thing I will do here is just check. So I'm going to replace this x here with 1/6. And I'm going to replace this x also with the same 1/6 because it's the same value. And I will put this into the calculator just to see if I get a true statement. So there's my question mark. Over the equal sign, 5 parentheses, 2 minus 10 parentheses, 1/6. And then I close that parentheses, but I got to close the other set of parentheses, enter. And on the left side, I got 5/3. But what about the right side? Negative 8 parentheses, 1/6, close parentheses, plus 3, enter, 5/3. So on the right side, I also got 5/3, which makes this a true statement, the original equation a true statement. Therefore, I know that if I replace x with 1/6, it will, in fact, give me a true statement. Now, just to emphasize this once again, if you had written this as 1/6 equals x, that's still a true, that's still going to give you the true statement, okay? It's just on the homework, I think all of them set up as like x equals, then it'll have a box right here that you got to fill in. So if you got to put a fraction, remember this would be like 1/6. And I don't know the difference between a forward or backslash, but I hope you do. Now there's our objective. I can solve an equation that requires many principles of equality, even when there are x's on both sides of the equal sign, because we can use principles of equality even on x terms, even when there's distribution, even when there's combining like terms. Boom. Now what this means as well is that as long as we have an equation that has only one letter in it, we should be able to solve it no matter what at this point, even though in the future we may see some that have decimals and fractions in them, which we will.